Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode MADI 1498. Number of subsequences that satisfy the given sum condition. This problem is a very good problem, marked as medium, and it has been asked in companies like Google, Meta, Amazon, Bloomberg, Turing. This question is going to teach you a lot of good concepts, and it is based out of two pointers, sorting, power of two, or you can say binary search as well. Let's have a look at the problem statement. Here what is given to us? Array of integer nums and an integer target. These two values are given to us. And what is expected from us? Return the number of non-empty subsequences of nums such that the sum of minimum and the maximum element on it is less than or equal to target. So this is something expected from us. So this nums array is given to us, and this target integer is also given to us, and what we have to return is count the number of subsequences such that in that subsequence minimum value plus maximum value is less than equal to target. If this condition is satisfied, that subsequence is contributing to our answer by 1. And they have also mentioned that the answer can be too large and written the modulo 10 to the power 9 plus 7. And the nums length will go till 10 to the power 5, and same for the values. Values will go till 10 to the power 6, and the target will also go 10 to the power 6. This is our problem statement, and let's try to see what will be the answer of this problem. Here this is the array given to us, and what we have to find out is subsequences such that the minimum value and the maximum value of that subsequence have a sum less than equal to target. Let's say if I am fixing 3, see, we have to fix at least one integer. Why? Because it is a non-empty subsequence. Because empty array is also a subsequence of this. We are not picking up any element, and the sum is also 0, that is less than equal to 9. So they have explicitly mentioned that it is a non-empty subsequence. So definitely we have to keep one item. Let's say I have kept 3 in my subsequence. Then what are all the other possible items I can pick as a part of my subsequence? Can I pick 5? If I pick 5, I will be having 3 and 5 in my subsequence, and 3 minimum value is 3, maximum value is 5. So 5 plus 3 is going to be 8, which is less than equal to 9. So if I am choosing 3 and 5, I will be having minimum value as 3 and maximum value as 5. This is acceptable because the sum of these two values is less than equal to target. And what about 6? Can we take 6 in that subsequence? Yes, we can also take 6, because 6 plus 3. If I am taking 6, 6 will be the maximum element, and 6 plus 3 will be less than equal to 9. 9 is less than equal to 9. So 6 is also considerable. But 7 I cannot take if I have fixed 3. So when I am fixing 3, it is my choice. If I want to take 5, I can take 5. If I want to take 6, I can take 6. But apart from that, no other item I can take. So here in this case, if I have chosen 3, I can either choose 5 or do not choose 5. Either choose 6 or ignore 6. And these will be the subsequences, right? So the subsequences are, let me write down somewhere. So first one is 3 for sure, because if we are not picking element. See, here in this case, at 5 we have 2 choices. At 6 we have 2 choices. So in total, how many choices do we have? 2 into 2, which is 4. Do not take 5, take 5. And then do not take 6 and take 6. 3, 6 and 3, 5, 6. So first one is something I have not taken. See, I have not taken 5, I have taken 5. So the whole is multiplied by 2. 3 to 5, I got 2 subsequences. Then again to 6, I got 2 more possibilities. So all those subsequences can have 6 or all those subsequences cannot have 6 in it. So here in total I got 4 subsequences. So for 3, 5 is going to contribute to the 2 subsequences, 6 is going to be contribute to 2 subsequences. So in total I am having 4. Answer is 4 so far. Now what else? Now let's try to fix the 5. If I try to fix 5, then 5, after 5 I cannot take any element. See, but there might be some elements from the starting of the 5, right? See, if we consider as a part of subsequences, there is no subsequence with 5. Okay, so let's try to understand the same example further. 3, 5, 6, 7. Let's say the example is something like this: 5, 3, 6, 7, right? And I am fixing 5. With 5, what are all the items I can take? I can take 3, because in this case minimum is 3, maximum is 5. I can take 6, no. I can take 7, no. I can take these. So with 5 I can take 3, and with 3 I can take 6. Here in this case what I'm trying to explain you is that first thing that you have to analyze is that they are asking us about the number of subsequences. So here these are 4 subsequences. So they only want the number. They don't want us to have the exact subsequence. So if they want us having the exact subsequence, we are concerned about the order. But they want just the number. So in this case, if I am considering 5 with 3, and or maybe writing 3 with 5, it doesn't matter. So this 5, 3 is equivalent to say that okay, with 3 I can take 5 and I can take 6. With 3 I can take 5, I can take 6, and 3 is going to be minimum number, and maximum number I can check from this array, remaining array. So what I'm analyzing here is that if we are sorting this array, let's say I'm sorting this array 3, 5, 6, 7, then if I start to fix an item, I fix 3. In that case my minimum is already fixed, and now I am only concerned about the maximum one. And maximum one I have to choose accordingly such that minimum plus maximum is less than equal to target. And what's the target here? Target is 9 and the minimum is 3. So maximum should be less than 3 plus maximum less than equal to 9. So maximum should be less than equal to 6, less than equal to 6. So this can be the maximum, this can be the maximum. So we will directly get to know that okay, if there is a subsequence, if 3 is the minimum in that subsequence, I can have either 5 as the maximum, either 6 as the maximum. Let's say if I am taking 5 as the maximum, whatever item I am placing at any position, I am not concerned about that. It means that we are going to capture every single subsequence where the minimum item is 3 and the maximum item is 5. So after that, between these 3 and 5, whatever item is coming, I can place it anywhere. So we are not concerned about the order here. We are only concerned that how many subsequences I can form, and that I will get to know if I am choosing 3 and if I am choosing 5. So how many possible subsequences we can have. So 3 is already fixed, and how many items after 3 I can pick? There is only 5. See, there is only 5, and if there is only one item after 3, the 5 can be there, cannot be there. So there is only 2 combinations, 2 subsequences, right? So with 3 I can either have 5 or do not have 5. If I am having 5, it will be 3 5 or 5 3. if let's say the order was something like this 5 3, actual subsequence is 5 3 as per this order. But even if we are considering 3 5, we are not bothered about that, because we as far as we are getting the number, we are good. So if I am fixing 3 here, I can choose 5 or 6. If I am choosing 5, contributing to the answer. If I am choosing 6, again multiplying with 2. This is the contribution to the answer. So with 3, whatever number of other items I can choose, my answer is going to be incremented by power of 2 comma number of items. So here number of item is 2. So 2 raised to power 2 is going to be contributed to the answer. So that is the main idea behind this problem. If I'm if I'm fixing 3, just get the number. So like let me write the array again, 3 5 6 7. So first of all, what I did is I did the sorting. And sorting usually take n log n of time. And after sorting, I am fixing 3 and then checking how many items I can have with 3. With 3 I can have 5 and 6 in my subsequence, and I am not concerned about the order as far as I know the numbers, know the items. So every item is going to contribute by 2. Can take 5, cannot take 5. Can take 6, cannot take 6. So with every single item, my number of items are getting double. Initially I was having only 3 as subsequence. Then this subsequence can either have 5, either having 5, it is something like this, or do not have 5. So it become double, 1 to 2. Now these subsequence can either have 6 or cannot have 6. Having 6, not having 6. So 1 to 2 and 2 to 4. So in this way it is increasing in terms of power of 2. So whatever are the valid items, contributing power 2 raised to power that. So what about 5? For 5 there is no item. 5, it means I'm fixing 5 as the minimum item. If I am fixing 5 as minimum, there is no maximum. So in this way we have to do it. So after sorting, we got the idea that keep on fixing item and check for the limit. And how do we check the limit? 3 5 6 7. How do we check the limit? If I am fixing 3 plus maximum less than equal to target, which is 9. So x less than equal to 6. So here this item I have to search here till what item I like I can pick, and this is something you can do using binary search, right? It means till 6. See, this portion is sorted and I can pick item till 6. So whatever is the last position of 6 or maybe the lower bound of 6, I can pick that. It means that for every single item I can use log n approach for binary search, but this approach can also be utilized using 2 pointers. Why? Let's say I have chosen 3. Can I choose 7? No. Then move to the left. Can I choose 6? Yes, I can choose 6. After that, let's try to increment 3. So when I am choosing 3 as a minimum and 7, I cannot 7 is something I'm choosing as the maximum element, then definitely there is only one possibility. Like if I'm incrementing 3, definitely like our minimum item and maximum item is going to cross the target. So there is no option of incrementing 3, and there is no decrement option for all of the for both of these values. There is only one value, just decrement the value of. You can utilize 2 pointer to get the answer. So let's say my left is on the 3 and right is on the 7. And I will check. I'm keeping the minimum item from the array as my minimum of subsequence and maximum item of the array as my maximum of subsequence. Then 7 plus 3 is 10, which is crossing my limit. It means I cannot take this combination. So I definitely have to reduce my right limit. If this is the case, now I have reduced the right limit, and now it is 6 as a right candidate and 3 as a left, and left plus right have a value of 9, which is less than equal to 9. It means this is going to contribute to the answer. And how it is going to contribute? After L, whatever is the number of item, power of that value. So R minus L is the number of item after L. 0, 1, 2. 2 minus 0, R is 2. So 2 items are there. So 2 raised power this is going to be contributing to the answer. So answer plus equal to this. So if we have captured all the answers starting with L, keeping the L as a minimum, then we can blindly move forward with L. Right, so this is like 2 pointer we can do. And let me just brief whatever we have discussed so far. First of all, we definitely are going to sort this array. Sorting the array, and once the array is sorted, I will try to utilize 2 pointer approach, left and right. Left value plus right value should be less than equal to target. If it is less than equal to target, my answer will be incremented by 2 raised power right minus L, and definitely left is done, so increment left. Otherwise what I have to do is decrement right section. So sorting the array using 2 pointers and then decrement the right portion. Sorting array is going to take n log n time, and this left plus R less than equal to T, answer plus equal to 2 raised power this is, see, this 2 pointer is going to take order of n time, but every 2 pointer is going to utilize this power of 2 operation. And this power of 2 operation, what can be the value of this R minus L? 2 raised power R minus L. This can be anything. Right can be the right side limit, n minus 1, and L can be 0. So in total it is going in the order of n. So 2 raised power n, 2 raised power 10 raised power 6 doesn't seem feasible to me, right? And this is something we are going to calculate every single time. Every time we are going to calculate the power of 2. So it doesn't make any sense. So if we write it along with our approach, it will definitely fail or give TLE, or sometime, or it will not give us the right answer. Why? Because in the problem it is also mentioned that we have to take modulo of 10 to the power 9 plus 7. If you are taking 2 to the power this, so you have to take accordingly that, keeping 10 to the power 6 as a modulo. So you have to write power by your own, and along with this, how many times we are going to call the power function. So instead what I can do is, we will do pre-processing. Pre-processing where every single power of 2, 0, 1, 2, 3 till n, I am going to pre-compute till n minus 1. So power of 0, 2 raised power 0 is 1, 2 raised power 1 is 2, and so on. 2 into 2, 4, 4 into 2, 8. And when I am storing it, I am also keeping the modulo with m. So I will pre-compute, and this pre-computation is going to take order of n time. Instead, every single time I am processing the power, so we can avoid this step, and it will remain order of n. So in total, the time complexity will remain n log n. Okay. So sorting I did 2 pointer, and this power of 2. So this is why I mentioned 2 pointers, sorting, and power of 2 at the top. Now let's write the code. I will do the live coding and you just try to get the idea whatever I'm doing. Let's start to code our approach. First of all, we are going to sort the array. Arrays dot sort nums, and after sorting we are going to maintain the 2 pointers. Int l is equal to 0 and r is equal to n minus 1. What is n here is nums dot length, and for the 2 pointers, while left is less than equal to r. If this l can be picked as minimum, r can be picked as maximum, then we are going to calculate how many subsequence we can contribute. Nums of l plus nums of r less than equal to t. Then answer plus equal to math dot power 2 raised to power r minus l, and after that this l is done. Otherwise we have only one option, decrementing r, and in the end we have to return answer. And what else? Yeah, answer should be initialized to 0. So this is our approach, very basic skeleton approach. And let me run over sample test cases if it is working fine or not. Yeah, sample tests are working fine, but it is going to fail over the larger inputs, and we have also not introduced this modulo into the picture. So this answer we are capturing here, answer should be taken as modulo. And what is this m? 1 2 3 4 5 6 7 8 9, that's power 9 plus 7. Okay, I have taken the modulo as well. So if I run it again, sample test cases will pass, but if I submit it, it should give me wrong or wrong answer. Yeah, wrong answer we are getting. Why? Because we have not introduced modulo in power function. Power function itself is not going to give us the modulo. Either we have to write the power by our own, but otherwise it is going to give us TLE, because 2 raised power 10 power 6 every time we are going to calculate. That is not feasible. So pre-compute, do the pre-processing like we used to do in prefix sum. So for this pre-processing, let me take a power array, new integer of size n, and for this power array, what is 2 is power 0? That is 1. For I equal to 1, I less than n, I plus plus. What is the next power? 2's power 1 is equal to 2 into 2 is power 0. Okay. Now as I have taken the power, I need to take the mode for the power as well. Power of I modulus equal to m. Power of I modulus equal to m. So this is the pre-computation of this power, and here instead of this statement, copy and here just directly use power. What power we require? R minus L. Let me run over sample test cases again. I'm submitting it again now. Now it should work fine, because yes, it is submitted successfully, and I hope you understood the approach. Why? Because this power of n, I made it to order of 1 time. So this is n log n time for sorting, order of n time for calculating the power, and order of n time for applying the 2 pointers approach. I hope you understood this approach, and in case you get any doubt, you just let's have a discussion in the comment section below. Thank you guys, thanks for watching, bye bye.